So from what we have discussed, okay, so I will just quickly glance through what we have covered. Okay, so we have defined what is one sample, what is the null and hypothesis, null hypothesis and alternate hypothesis. Okay, so I showed you what is one-tailed test and what is two-tailed test and how to correctly construct your H1. Okay, given what is the keyword or what is the clue, okay, given from the statement. Okay, if the statement points you to something increasing higher, if the value has increased, so that will point to a one-tailed test on the right side of the distribution. If the value of if the keyword used is the value has decreased, declined, okay, so that will be the opposite of one tail on the right, it will be one tail on the left. Okay, but if the keyword is something that you want to see or you want to investigate if there is a change or there is any difference, okay, on the value on the mean that you want to investigate, so that will point to a two-tail test. So the difference between one-tail test and the two-tail test is there's a lot of difference. Okay, one of course is in the construct of your H1 and also your H0. Okay, basically your H1 will determine whether your H0 is correct or not. If you decide it to be a two-tail test like this example, and so your H0 will also be a two-tail, meaning using the equal to sign. Okay, and then from the critical value, the level of significance given to you, in this case 1%. So you need to divide the alpha. Okay, alpha means the level of significance. If it is 1%, then you need to divide into two, one on the left tail, the other one on the right tail. Okay, so if it is 1% in this case, so this part will be 0.005. Okay, whereby 1% divided by 2. So this also will be 0.005. Okay, so that will leave you with this remaining area, okay, to be 0.495. Okay, because we know that the distribution is symmetrical. So half side will be 0.5. If this tail on the right is 0.005, so the remaining will be 0.495. So if you are using Z table, so 0.495, you check in the table, the closest one will be 2.58. So, okay, of course, in the slide, it shows 2.576, but you can use 2.58 as the critical value. Okay, remember, critical value is will be you base the critical value based on the level of significance, okay, and also whether it is a one-tail test or a two-tail test. Okay, so it will be step number 4. Okay, decide what is the decision that you want to make. Okay, in step number 4, what is your decision? Meaning, how are you going to reject the null hypothesis? Okay, so in this case, as I mentioned before, in step number 4, if you are using a Z test, okay, the word critical Z you need to replace. You need to fill out. Okay, what is the value here? So in this case, it will be plus minus 2.58. Okay. So, because in step number 4, you should have known what is your critical value already. So, if the calculated Z that you will perform, that you will determine in step number 5 is bigger or lower than this value, means that the value is inside the area of rejection, you are going to reject the null hypothesis. Okay, remember, the decision is always in terms of whether you reject or do not reject the null hypothesis HO, okay, not H1. Okay, but your calculation is supposed to support H1. So there is a two different things that you need to be aware. And then when you do the calculation using the simple formula, okay, and then you're gonna make your conclusion in 3 different parts. Okay, the first part is whether the value that you calculate, the calculated Z. Okay, here is calculated Z. Okay, today we're gonna see a calculated T. Okay, calculated Z, whether it is inside or outside the area of rejection. So 1.55 is outside the area of rejection. Okay, so meaning that point number 2, H0 is not rejected. Okay, so if it is inside, then we say H0 is rejected. Okay, but because you cannot reject, meaning that we conclude that the mean is not different. Okay, it's not different means your H1 is again whatever that you conclude in the third point, okay, the third point here should refer to your H1. Okay, what is your H1? Your H1 in this case is that the mean is not different. The mean is different. That is what your H1 is. Okay, if you check back your step number 1 here, okay, mean mu is different than 200, okay, not equal to, okay, or you can say not equal to, or you can say just different, okay. So either it's not equal to 200 or different than 200, okay. So because you cannot reject means you need to add the word not, okay. So we conclude that the mean is not different, okay. So if you reject, mean you remove the word not, you just mention what is your H1. Your H1 is the mean is different from 200. So that is if you are doing a two-tail test. So we also look at if the test becomes one tail, okay, because the keyword that they change from the word different to more than, okay. So you want to prove that the mean now is actually more than 200. So this actually will point to your H1. So your H1 will be mean or mu is greater than 200. So then if you construct this this way, so your H0 will be less or equal to. Remember the H1, the H0 is always the opposite, okay, of H0, sorry, of H1. And the sign for H0 can only take whether equal to, less or equal to, or more or equal to. Okay, only these three for H0. So it depends on what you choose for H1. If H1 is more than, then the opposite will be less or equal to. Okay. So this is the second example. So again, everything is the same, but because you are doing a one-tail test, okay, and your alpha is 1%, so you don't need to divide the 1% into 2, okay, because that is only for a two-tail test. You only divide the alpha into 2 if you are doing a two-tail test. But if it is a one-tail test, you take the alpha as it is 1%, and you need to draw your area of rejection, okay, because it is one tail on the right, because your sign is more than means you are pointing on the right. If it is less than, then it will be the area on the left, okay. But because in this example we are doing one tail on the right, so the area of rejection 1% will be this area 0.01. So that leaves you, if you split the graph into half, okay, so the total will be 0.5 minus by 0.01. So this area will be 0.49. So you're going to check the Z table, the area, the value of Z closest to 0.9. So that will be your critical value, and you should get 2.33. Okay, of course, the slide gives you 2.326, but you can use 2.33, okay, as shown from the table. Okay, so you mark that line, okay, as your, so you need to draw your normal diagram, okay, show what it, and then you need to, so it will be something like this, okay. So you need to first show the value in the middle equal to 0, and then you need to draw the line, okay, that points to your critical value. So this will be 2.33, and you need to shape the area of rejection, meaning if it is a one-tail test on the right, so the area of rejection will be on the right side of the tail. And the line that divides between the reject and do not reject is the 2.33, the critical value. Okay, and then the rest is the same. Okay, so you need to fill up, you need to follow the step 1 until step number 4. So step number 4, reject is null if Z, if calculated, okay, not critical Z, okay, if calculated Z is bigger than 2.33. Okay, so in this slide you need to change, you need to fill up what is the critical value, okay, and mention here. So this will be step number 4. So in your assignment for this chapter, okay, later on once we finish chapter 9 on the 2 sample hypothesis testing, okay, you will be given you will be given the questions from books or past years. Okay, so I will inform what is the group that you belong to. Basically, I will just follow the sequence in your syllabus. Okay, so that one will be mentioned later. So I will send you the list of the group members. So you need to start communicating with your group members when we start. Okay, when you need to start doing the assignment. Okay, so in your solutions for any question related to hypothesis testing, okay, you need to answer according to the step 1, step 2, step 3 as what you see in the slides. Okay, so in step number 3, the decision will be reject H null if calculated Z is more than 2.33. Okay, so then you perform the calculation, and do not forget this diagram as well. So this diagram that shows the area of rejection, this will be part of the solution as well. Okay, you cannot answer a hypothesis testing question without showing the area of rejection and show where is the critical value. Okay, so this just to show that you understand the concept of one tail test or two tail test, one tail on the right or one tail on the left. Okay, and then step number 5, again in this example, because you are doing a one tail test on the right, so okay, the answer should be constructed in the 3 sentence. Okay, the first, whether it is inside or outside, and then second part, whether you reject or do not reject. The same conclusion you make because the value is still less or is still outside the area of rejection, and you add the word not lah. Okay, so the mean is not more than 200. Okay, so if you reject, means the mean is more than 200. Okay, so of course you see that this sentence is slightly different than the previous example, because basically this just refer to the statement of your mu, because your mu that you mentioned, okay, H1 and H0, okay, H1 mu is more than 200. Okay, so what is mu here? Mu here, according to the statement, is the mean number or the average number of desk assembled. So you can write this way, or you can just use the word mean. Okay, but if you write this way, at least it refers directly to the problem that you are doing. So both are still correct. Okay, so that will be the solution if you are using Z distribution. So Z distribution is when sigma is known. But when sigma is unknown, meaning that you derive the standard deviation directly from the sample. So, similar to how you do the hypothesis, the confidence interval in the previous chapter. Okay, so you are going to use the T distribution. The rest is the same. Okay, meaning that from step number 1 until step number 5, okay, the only difference is how you derive the critical value. In terms of deciding what is H1 is the same way. Okay, but because if you decide it's going to be a T test, okay, the way you determine the critical value will be the same way how you determine in your confidence interval. You need to use the T table. Okay, if the sample size, let's say, is 20, then your degrees of freedom will be 19, n minus 1. So you need to refer to the table and see how you gonna determine the critical value. Okay, so we look at this one example first. Okay, so you are given one scenario. Okay, the mean is reported to be the mean cost of process a claim is $60. Okay, and then they do a survey. Okay, from a 26 sample. Okay, the mean the information is given below, and so this is what you want to test at 1% level of significance, or at 0.01 or at 1%. Is it reasonable? The claim now is less than 60. Okay, so the word less than means this is what you want to study, you want to investigate. Okay, they mentioned that previously is 60 from history, okay, from previous information, but when they collect a new information, a new sample, okay, they believe that actually now the claim actually is less than 60. It's not $60. So the word less means you are doing a one tail test on the left. Okay, less than. So this is how you're going to construct your H1. So because it is less than, your H1 will be, your H0 will be more or equal to. So this will be H1, this will be H0. And in this question, you are not given the mean and the sigma yet. So you need to calculate this manually from the information given. So by now, you should know how to derive the mean and the sample standard deviation using your calculator or using the online calculator. Okay, so you applied this earlier in the semester in chapter number 2 or 3, okay, when you need to calculate the mean and standard deviation. So there's nothing new here. Okay, so first, okay, construct what is your H1 and your H0. So your H1 is the mean is less than 60. okay, because the word less than, okay, and then so this is what I mentioned just now. Okay, step number 3, you are going to use the t distribution because sigma is unknown. Okay, so when you decide to use t-test, okay, or the t distribution, so the critical value will be based on the t table, okay, not on the z table. Okay, so determining the critical value using t table actually is easier than the z, because you don't need to you refer directly from the table. Okay, no need to refer. Okay, you need to divide or you need to minus by 0.5. Okay, that's what you did for z. Okay, so actually using t distribution is more straightforward. Okay, so here okay, so it is a one sample, a one tail test. Okay, and your alpha is 1%. So you need to know whether it's one tail or two tail and determine what is your alpha and also what is your sample size. Your sample size is 26. So you need these 3 information: one tail test or two tail test, what is your alpha, and what is your sample size, your n. Okay, so if you look at the t table in your textbook, okay, in your ebook, so you use your t table before in the previous chapter. Okay, so you will notice that in your t table that there are 3 rows. Okay, the first row will be the confidence interval value, the one that you use for chapter number 7, and then the second and the third rows will be for hypothesis testing value. Okay, the second will be just for one tail test if you decide to use a one tail test, but you are going to use the third row if you are doing a two tail test, meaning that the second row is only for more than or less than. Okay, the third row will be if you are testing for not equal to. Okay, meaning that if your H1 is not equal to, you're going to refer to the two tail test. If your H1 is more than or less than, meaning that you are going to use the one tail test. So in this example, your test will be one tail test, okay, and then your alpha given from the question is 1% or 0.01. So you refer to 0.01 inside the one tail test. Do not refer to 0.01 in the two tail test. You can see that it is different value. Okay, if you use this one, then it will be wrong. The critical value will be wrong. If you choose the wrong critical value, you may end up coming up with a different or wrong conclusion. Okay, because the value is different, you may end up rejecting if actually you cannot reject the H0. So refer to the correct row in the T table. So in this case, we are referring to the one tail test at 1%. Okay, and then the DF. DF is n minus 1. Okay, similar to what you did before in the confidence interval. So your sample size is 26. So 26 minus 1, you will get 25. Okay, so that is why you refer to 25 here. Okay, 25 under 1%. So your critical value will be 2.485. So I'm sure the way that how you read the T table is pretty much the same as what you did for the confidence interval. So the main thing is referring to the right row and also to the right column in there. So DF is n minus 1 for this chapter. Okay, n minus 1. So 25 under 1%, 2.485. So in step number 4, when you decide to construct what is your decision, okay, reject H0 if, okay, okay, so your decision will be based on what you decide in your H1, correct? Because your H1, you want to prove that, you want to show that actually now the mean is less than. So in step number 4, reject H0 if computed T should be less than. So whatever direction of sign that you put here, whether it's less than, more than, or not equal to, must be the same as what you choose for your H1. If your H1 is less than, okay, then step number 3 will be, step number 4 will be computed Z is, computed T will be less than. Okay, here okay, you need to fill out what is the value. So it will be negative 2.485. Okay, So make sure that you put the negative sign, because although from the t table only gives you positive value. Okay, so if you are doing a one tail test on the left, okay, so because the value is on the left side of the distribution, anything left on this will be negative value. So you need to put negative 2.485, okay, not positive. Okay, so if you end up just writing 2.485, okay, so it's wrong lah. So you need to show that you need to write reject H0 if calculated T is less than negative 2.485. So this will be the correct way to write down your step number 4. Okay, first, uh, of course, do not write Z lah. If you are doing a T Z distribution, then this will be Z. But we are doing T distribution, so computed T, and it should be less than, because this is what your H1 is. And why negative? Because when it is less than, automatically it will be negative. Okay, because you are looking at the left side of the tail, and then you perform the simple calculation, x bar minus mu divided by the standard error, sigma over n square root, just plug in whatever value. Okay, here of course, okay, the value that you see here, 56.42 and 10.04. So these two values you must calculate manually. Okay, 56.42 and also 10.04. These are not given from directly from the question, but can be calculated manually from this raw data. So I'm not going to show you how to calculate this. Okay, so it's your duty to use your calculator or the online calculator. Okay, make sure that you calculate using the sample standard deviation, okay, not the population standard deviation. Okay, so key in this data, okay, and then you should be able to prove determine that the mean x bar will be 56.42 and the sample standard deviation will be 10.04. Okay, so once you determine that, then you can perform this calculation. So in question like this, where you don't have that, where you are not given directly what is the mean, what is the sample standard deviation, but instead you are given raw data like this. So you have one extra task to do lah, which is not really that difficult. Okay, so then once you obtain that, you can perform the calculation. Okay, so finally step number 5, same as before, you need to construct according to the 3 steps, the 3 sentence rule lah. Okay, first whether it is inside or outside, and then whether you reject or not, and then if you do not reject, you need to add the word not lah. Okay, so this is again your critical value is negative 2.485. Your calculated T is only negative 1.8. Okay, so negative 1.8 is clearly outside the area of rejection. Okay, so negative 1.8 does not fall in the rejection. So H0 is not rejected. Okay, because you cannot reject means that sentence number 3. Okay, again you must refer to H1. So what does your H1 means? Says you want to test that mean is less than 60. Okay, so because H0 is not rejected, we have not demonstrated. And these are different ways to write sentence. Okay, we have not demonstrated that the mean actually is less than. So basically this is like a negative statement. If you want to write the same way as before in the previous example, you can just write we conclude that the mean is not less than 60. Okay, or the mean cost cutting measures is not less than 60, because you need to add the word not, because you cannot reject. Okay, but if you reject, you just say that we conclude that the mean is less than 60 if you reject lah. Okay, but if you do not reject, add the word not. Okay, so the same the way to conclude is exactly the same way as whether you are using Z or the T distribution. The only difference is if you use T distribution, you need to use the T table, okay, to determine your critical value. That's it. Okay, and also if you are given question like this, okay, you need to calculate manually what is your sample standard deviation. Okay, so here again another question, but if you go straight to the keyword here, you want to prove that the new machine is faster. Okay, but you need to understand the word faster, okay, does not mean that the value is bigger, because here is in terms of time. Okay, time faster means if you say that previously it takes you 1 hour to drive from point A to point B. Now it only takes you 20 minutes, okay, to get from point A to point B. Meaning now it's faster than before. Faster in terms of time means that the value is getting lesser. It's not getting bigger. So you need to understand the statement. Okay, bigger, yes, higher than, the value has increased. Okay, but in this particular example, okay, because what they measure is in terms of time. Okay, 250 per hour. Now it is the new machine. Wait, is it in time or quantity? Oh, okay, okay. Sorry, my mistake. Okay, so now basically what you are testing is the value now has increased. Okay, you can see it clearly here from the history or previous information is 250. So this will be your mu. Okay, but from a sample of 10, okay, you can see that this information here comes together in one sentence. From this 10 sample, you get the mean to be 256. So this clearly will be your X bar. X bar means the mean taken from the sample. Okay, so this will be the X bar and the sigma is 6. Okay, clearly mentioned here. Sample standard deviation. Even though if I remove the word sample here, okay, you should know that this standard deviation actually refers to the sample of 10 because it comes together in the same sentence. Okay, but in this example, it is made much more clearer because the word sample sigma is mentioned directly. So so this question is easier than the previous one because you are given directly what is the X bar, what is the standard deviation, okay, equal to 6. And now your alpha is 5%, okay, not 1%. And you want to prove that now the machine is faster in terms of you can produce more. Previously 250, now the value has increased to 256. So your H1 will be mean or mu bigger than 250. So because this is bigger, the H0 will be less or equal to. So that's why I mentioned in the previous week, always start with your H1 first. Construct your H1. Once you are clear what you want to do, so the opposite will be true for H0. Okay, so step 1, your H1, your H0. Step number 2, what is your alpha given, which is 5%. Okay, step number 3, you're gonna use T because, okay, this one is, you just, okay, this part, you just delete this one, okay. You just mentioned use T because population sigma is not known. Okay, about the sample size less than 30, that one is, yes, it's true, but okay, we do not want to touch on that. Okay, as long as the sigma is not given, you are going to use T. So in your slide, you can just remove that part there, okay, because, so just mention, we are going to use T because population sigma is not known. Okay, so and then you in step number 4, okay, so you need to make up your decision. Okay, reject H0 if T is bigger than 1.833. Okay, so how do you get 1.833? Please go and check, okay, from your T table. Okay, your sample size is 10, so your DF will be 10 minus 1, which is 9 lah. So you're gonna refer to 9 in your T table under 5%, 0.05, okay, under 5% alpha, okay, using one sample test, okay, because your one tail test, okay, because your H1 is more than means a one tail test. So refer to the T table, one tail test, okay, 5% alpha, DF equals to 9, you should get 1.833 as your critical value. Okay, so of course in this slide here, okay, they don't show you this the area of rejection. Okay, so in your own, if you were to answer this question, so you need to show where is the area of rejection, which is it will be one tail test on the right. Okay, so you need to highlight the area on the right, and then this critical value, okay, this value will be 1.833. Okay, so this is how you gonna show or draw your area of rejection lah. Okay, so and then step number 5, okay, again, make your conclusion. Okay, this statement is a bit brief. Okay, they don't so you need to add one more sentence before. Okay, 1.833 is outside the area of, 3.162 is inside the area of rejection, okay, because your critical value is 1.833, your calculated T is bigger than that, 3.162. So the first sentence should be calculated T or 3.162 is inside the area of rejection. So H0 is rejected. Okay. Why reject? Because this value 3.16 is bigger than 1.833. Okay. So the mean, so you can conclude in the third sentence, the mean is more than 250, which is what your H1 is. Okay. Your H1 is the mean is more than 250. Okay. Because you reject means that you can support this statement. Okay. Because H1 is the mean is bigger than 250, bigger than or more than. So you can, so the sentence you just mentioned, the mean is more than. Okay. If you do not reject, you need to add the word not. Okay. The mean is not. But in this case, because you reject, okay, so no need to add the word not. Okay. Not is only when you do not reject. Okay. So I think these two examples is pretty clear and straightforward. Okay. When are you going to use Z? When are you going to use the T distribution? Okay. Okay, the last part of the syllabus, okay, similar to your confidence interval, you have the proportion. Proportion means you are using Z, okay. So Z means in this syllabus, using Z table, there are three conditions. Okay, one is when you when the sigma is known. Okay, okay, when the sigma is known. Okay, in the first part of the slide. Okay, what we discussed last week. Okay, but secondly, so this one you are going to use the Z distribution. Okay, and then when sigma is unknown, you are going to use the T distribution as what we just discussed just now. Okay, when the sigma is with unknown standard deviation. And finally, when if you are using proportion, okay, proportion is when your information is just based on percentages or proportion. It's similar to your CI, confidence interval topic. Okay, so the formula to calculate the Z value, the calculated Z, is based on this simple formula, P minus pi divided by pi 1 minus pi over n square root. Okay, so again, you are going, if you end up using proportion, the way to construct or calculate the critical value using Z is the same way as what you refer before in the Z distribution. Okay, the only difference is formula to calculate the Z value. Okay, instead of x bar minus mu divided by sigma over n square root. Okay, but now you have this formula here. Okay, so the rest is the same. Okay, there is no difference between step 1 to step number 5. Okay, so I'm just going to be very brief in this part. Okay, because everything else is the same. The only changes is the formula to calculate the Z value. P minus pi, P is the sample proportion, minus the population proportion, divide by the value of the population proportion. Pi 1, if pi is, let's say, is 0.3. So this will be 0.3 multiplied by 0.7 divided by the sample size. We take the square root. Okay, and then you solve, you should get your calculated Z. Okay, the critical value of Z is the same way as your how you determine the critical Z value under Z distribution when sigma is known. So we discussed that in great detail last week. Okay, so here you have this one information. Okay, so you can see that again, okay, if you are using proportion, okay, you don't have any information about the standard deviation, what is the mean value. Okay, what you have is something in terms of percentages, 80%. Okay, so here is what you have. Okay, so the governor need to get, governor is something like the YB lah, yang berhormat. Okay, need to get at least 80%. So what is the chance of governor re-election? Okay, so this question, okay, this example for me is a bit is a little bit strange. Okay, but never mind. Okay, in your exercise or in your assignment, it should be more straightforward. Okay, because the way they construct the H1 is less than. Okay, for me it should be more than lah. Okay, because if the governor were to be re-elected, so he should get more than 80% of the vote. Okay, but never mind. Okay, so I just want to focus on how you do the testing. Okay, but the information given to you is very simple. From the 2,000 sample voters, 1,550 plan to vote for the governor, meaning he will get around 1,550 votes from the 2,000 voters. So the value of the P, the proportion will be 1,550 divided by 2,000 lah. Okay, so the rest is the same. Okay, but okay, I'm not going to change this one. So assuming that it will be pi less than 0.8. So if this is 1 tail on the left, okay, so if this is less than, so your H0 will be more or equals to. Okay, so just focus on the process of the problem. Okay, not so much about why is it less than. It is supposed to be more than. Never mind. Okay, so the rest is the same. Your alpha is 5%. Okay, so okay, this one. Okay, so if you are doing a proportion, okay, no need to mention this one. Use Z distribution. As long as you are doing proportion, it should be using Z distribution. Okay, so use Z because it is proportion. Okay, proportion we always use Z. Okay, so step number 4. Okay, again, because this is a one tail test on the left. Okay, in this example, it is one tail on the left. So when you draw your normal curve, you should highlight the area on the left because it is less than. Okay, so first you need to know whether one tail on the right or one tail on the left. So because your sign is less than, it should be one tail on the left. Okay, next is what is your critical value, the value that divides between rejection and do not reject. So because the alpha is 5%, so this value will be 0.05. Okay, 0.05. So that means this remaining area will be 0.45. So you are going to refer to 0.45 in the table in order to determine what is the critical value. So you can see here 0.45, okay, is around 1.65. So that's how you get negative 1.65. Okay, you need to add the word the value negative because you are doing one tail on the left. So the rest is the same. Okay. Step number 4, okay, reject is null if Z calculated Z is less than negative 1.65. So that should be your step number 4. Okay, so this will be negative 1.65. Okay, so in step number 4, you need to add the value here. Okay, so the rest is the same. Okay, of course the formula is different. P minus pi divided by the standard error. So P will be 1550 over 2000 minus 0.8. So where do you get 0.8? It's from the statement here. Okay, from the history. History shows that 80%. You need to get 80% in order to be elected. So that will be your population mean. Okay, so your population proportion, the pi value. Okay, so this minus this divided by the value of the formula, as what you see here. So, and we get the calculated Z is equal to negative 2.8. So negative 2.8 is smaller than negative 1.65, meaning the value is inside the area of rejection. Okay, so negative 2.8 is somewhere here. Okay, so meaning that you are going to reject the null hypothesis. Okay, remember, if you reject, you need to add the word not in your third statement. Okay, so never mind. Okay, how you write this conclusion. If you want to make it simple, okay, the third statement you can just mention. We can conclude that. Okay, first, what is your H1 just now? Our H1 here is pi is less than 0.8, correct? So if you were to write the third sentence in this case, because you reject, meaning that you can support H1. Okay, you reject H0 means that you can support this statement. So you can just mention that we conclude that, okay, we conclude that the proportion the proportion, the population proportion, okay? Or you can just say the proportion of votes, okay? Okay, whatever lah. I mean, you need to refer to the actual case that we are referring to. I think it's something to do with votes. The proportion of votes is less than 80%. Okay, we conclude that the proportion of votes is less than 80% because you reject each non means that you can support this one. Okay, so when in your third sentence, you should write if you want to more straightforward. Okay, you so just follow what you write in your H1. Your proportion, the population proportion will be less than 0.8. Okay, so that should be the statement, the last sentence of your conclusion. Okay, so I think that's it for chapter number 8. Okay, so of course, okay, I will be giving you some questions for you to do, okay, and submit in your OL. Okay, just to make sure that you following what is happening throughout our 3 classes, okay, from last week plus this week. Okay, so most of the questions that I will give you will be on the T distribution. Okay, because I think that is more relevant. In fact, the proportion is less popular. Okay, so don't forget your test tomorrow, test number 3. Okay, even your test tomorrow, we omit the proportion topic. Okay, even though it is part of your syllabus, but in terms of the uh, in terms of the actual world, I mean real research scenario, okay, we don't really use proportion in the real research. Okay, it's not really that common. So even in your assignment or in your exercise today, okay, most of the questions will be on the T distribution, and maybe a few on maybe 1 or 2 will be on the Z distribution, just to make sure that you know how to determine the critical value, okay, from Z versus the critical value from the T distribution. Okay, so let me go through what the okay, so for your exercise, okay, so I'm giving you more time so you can submit your exercise later tomorrow evening. Okay, so it shouldn't take you more than I think half an hour or 1 hour to do. So so please do these questions. Let me okay. Okay, question number 18. Okay, 18. So and then question number. Okay, if you see any question on the p value, okay, so the p value for the t test, I have not shown you how to do it. Okay, I will only show you in the next chapter. So if you need to calculate the p value, just ignore. So no need to answer that. Okay, so just focus on step number 1 to step number 5. What is the H1, H0 until you arrive at the conclusion. Okay, the p value I will explain to you for the t test, for the t table. Okay, when we start on the next chapter, chapter number 9. Okay, so question number 18, question number 20, and then question. Okay, question 24. Okay, so 24, I can mention to you, this is using Z distribution. Okay, because the sigma is given in advance. Okay, so 24 will be on the Z distribution. Then, okay, question 26. This, I can tell you, it is on T distribution. Okay, because the sigma is mentioned together with the sample of 100. Okay, so you have how many questions just now? Question 18 and question 20, both will be on the T distribution. Question 24 on the Z. Okay. Question 26 again on the T distribution. Okay, and then maybe one more question. Okay, Okay, the last will be question 34. Again, this is on the T distribution. So I think you have only one Z distribution question, question 24. The rest will be on the T distribution, 18, 20, okay, 26, and also 34. Okay, so you can find them in your textbook in chapter 10. Okay, so I will put up this video, and then if you need to refer back to the questions, okay. So each question I think should take you less than 10 minutes to do. Okay, even if you were to answer this in a real exam, okay, one question shouldn't take you more than 6 minutes to do. Okay, so you have the tool to do it. Okay, your calculator, your online calculator to calculate the mean, the sample standard deviation for each of the question. For Z, for T, okay, for 24 is you are using the Z distribution. Okay, so I think we'll leave it to you. So we are finishing earlier today. Okay, so you can